Part A, finding the sine, cosine, and tangent of the following triangles. We'll leave the answers in exact form. So to review with you, SOHCAHTOA, these are the main three trig functions. Sine, the way you remember sine is so, which is opposite over hypotenuse. There's where the O and the H come from. Cosine, the way you remember that is ca, adjacent over hypotenuse, so the A and the H in the beginning. And then tangent, the way you remember that trig function, is toa, and that is opposite over adjacent. Remember, if we're working with, let's say, angle B, side opposite is over here with line segment CA. Side hypotenuse is opposite the right angle, and then side adjacent is right there. All right, here's an example. Find the sine, cosine, and tangent of this trig or this triangle. So we're going to be working with angle A. So here's our angle A. Before you find the sine, cosine, and tangent, identify the three sides. 9 represents the length, which is side opposite. 15 represents the hypotenuse. And then 12 represents the adjacent. All right, so let's find the sine first. So sine is found by opposite over the hypotenuse. So opposite is 9 and the hypotenuse is 15. We do want you to reduce it down to its lowest value, so this would reduce down to 3/5, and then leave it alone. The next one, the cosine of A. So to find the cosine of this, it's ca, adjacent over the hypotenuse. So adjacent is 12, and the hypotenuse is 15. We reduce that down to its lowest form, so we're going to reduce by 3. So we left with 4/5. Last one, tangent of angle A. Tangent is found by opposite over adjacent, toa, to remember. So opposite is 9, adjacent is 12. So 9/12, or if you reduce that down, you're going to divide by 3, so that's with 3/4. So those exact three values for the sine, cosine, and tangent of angle A. Here's a second example, a little bit different on this one because we have a radical with one of the lengths. And we're going to work with angle B this time. So here's our angle B. Identify the three sides. Here's side opposite, side hypotenuse, side adjacent. All right, so let's go ahead and find the sine of B, the cosine of B, and the tangent of B. So remember, sine is opposite over the hypotenuse. So opposite is 1, hypotenuse is square root of 5. So 1 over the square root of 5. Now if you remember back to radicals, we do not want to leave an answer like this where you have a radical in the denominator, so we rationalize it. So we're going to multiply the numerator and the denominator by the square root of 5. Now let's multiply across. We get 1 square root of 5 in the numerator, and then square root of 5 times square root of 5 is a square root of 25, or reduces to 5. All right, cosine. Cosine of angle B, ca, adjacent over hypotenuse. So adjacent is 2, hypotenuse is square root of 5. So 2 over the square root of 5. Again, we can't leave the answer like this, we have to rationalize it. So we'll multiply the numerator and the denominator by the square root of 5. Let's multiply across. 2 times square root of 5 is 2 square roots of 5. Multiply across, square root of 5 times square root of 5 is 5. So exact value is 2 square roots of 5 over 5. Last trig function, the tangent of B, toa, opposite over adjacent. So opposite is 1, adjacent is 2. So 1 over 2. We can leave it like that.